we recently made a frightening discovery. Parts of the universe around us could literally come to an end at any moment, even right here, right now. And it's possible that before we even reach the end of this story, all of humanity could be annihilated by a quantum death bubble moving at the speed of light. Let me explain. You'll see, it's fascinating. And if I do a decent job, by the end of this video, which I hope will blow your mind, you should be looking at the matter around you with a suspicious eye. We know that the universe had a beginning, and everything suggests that it will also have an end. The question of how the cosmos will eventually die has long remained out of reach. But over the past few decades, increasingly precise data collected by our telescopes and particle accelerators have made it possible to clarify the three main possible scenarios for its long-term evolution up to its total disappearance. Among these three scenarios, each more terrifying than the last, and which we have already discussed at length in previous videos, there is the chilling scenario of the Big Freeze, which is now considered the most likely, and in which the universe dies in silence, total darkness and cold, a victim of the continuous expansion of space. An expansion that, over dizzying spans of time, during which all the stars go out and matter evaporates, eventually plunges the universe into a state of thermal death. In the second scenario, called the Big Crunch, the universe, as if too heavy, manages to slow down over very long periods of time. Stop, then reverse the expansion of space before collapsing in on itself, until all the matter and energy in the cosmos end up crushed into a singularity. A point in space of infinite density, where even time is annihilated. The good news is that this scenario of an apocalypse of heat and density is now unlikely, because gravity seems to be completely overwhelmed by the rates of expansion of space. Finally, in the third scenario, called the Big Rip, the universe dies in a literally heartbreaking way, because it ends up being destroyed through the exponential expansion of space, which, over phenomenal periods of time, manages to surpass the reach of all other forces of nature, to the point of tearing apart and dismantling all the components of reality in a relentless and unprecedentedly violent process until it rips apart the very structure of space-time itself. Quite terrifyingly, the scenario of the universe dying by being torn apart is, today, still on the table. Although they differ in their stories, these three scenarios for the death of the universe, each frightening in its own way, have one thing in common. They all happen slowly and gradually. We see them coming. And above all, they don't start anytime soon. None of them will happen for at least tens or even hundreds of billions of years. And the Big Freeze is so far away from us in the depths of time that, in the end, it even comes close to the very notion of eternity. In other words, each of these scenarios offers the comfort of being so far in the future that there's no reason to worry about them. You have plenty of time to finish this video before the universe disappears, except that we've recently discovered that, in fact, there's a fourth possible scenario. A scenario that is certainly the most unsettling of them all, because in this one, the end of the world doesn't announce itself. You don't see it coming. It happens without warning, taking the form of an expanding bubble of annihilation that moves at the speed of light and causes, as it passes, an instant and silent collapse of reality. Cheery stuff. To grasp the full depth of the scenario where the universe dies by the expansion of a quantum death bubble, let's start by stating the obvious. We live in an apparently well-ordered universe. The physical laws are stable. The fundamental constants of nature seem to be finely adjusted. And their values do not change over time. In every direction we look, even in the regions farthest from us in time and space. Everywhere in the universe, stars shine in the same way, and matter here as elsewhere always behaves as expected, obeying the sacred laws of gravity, electromagnetism, as well as the nuclear forces. And this, without wavering, for 13.8 billion years. But this stability may be an illusion of scale, an apparent calm that could conceal the possibility of an instant apocalypse. Because since the beginning of the 20th century, particle physics has revealed, by studying the nature of the vacuum, that it is not completely empty. Even in the absence of any particles within it, this fundamental playing field on which matter, energy, and the laws of physics operate quivers, bubbles, and fluctuates. With the discovery of these strange properties of the vacuum, a most troubling hypothesis was born in the equations, and which until now has never been refuted. The idea that the vacuum we observe, once all the particles are removed, is only an apparent vacuum. There would exist, at a more fundamental level, an even more minimal state, another form of vacuum that would be much more stable. But if the vacuum we study is only a temporary version of a deeper state, then the consequences are as fascinating as they are frightening. The cosmos could harbor a fatal instability capable of destroying parts of it at any moment. In the collective imagination, the vacuum is nothing. It's an absolute void, an absence of everything. And that's also how scholars, from the Greeks to the Newtonians, imagined it for a long time. But in the 20th century, the discovery of the quantum world shattered that representation. To really understand why, let's dive for a few seconds into the fascinating world of the infinitely small. When scientists study tiny volumes of space in the lab, from which they've patiently removed all present particles, what they observe is not the absence of everything. It's an almost minimal and fluctuating level of energy, from which pairs of particles and antiparticles with measurable effects can spontaneously emerge, only to annihilate each other and disappear within just a few nanoseconds after materializing. So the quantum vacuum we observe in our laboratories, like the one that exists in the space between stars and galaxies, is actually far from being nothingness. What we call a vacuum is nothing more than the vibrating fabric of reality, a scene filled with quantum fields, which have a geometry, a background energy, and are teeming with events as fleeting as they are elusive, manifesting even after you have removed everything from it. And the existence of these quantum fields is of utmost importance. Without them, nothing we know could exist. And where it gets particularly confusing is that when studying one of these fields, the Higgs field, researchers discovered characteristics that raised more than a few eyebrows and could one day, believe it or not, destroy parts of the universe. This Higgs field, which was first observed during experiments conducted at CERN's Large Particle Accelerator in 2012, plays a central role in the universe. Because it determines several fundamental constants of nature and gives mass to particles through its famous boson. However, by studying the behavior of these Higgs bosons, it was discovered that the field from which they originate appears to have an instability. Indeed, unlike all other known quantum fields, the Higgs field is the only one whose minimum energy is not zero. So clearly, this discovery leaves you completely shocked if you're like me and part of the general public. But if you're a physicist, it's a big problem that might keep you up at night. Because it's as if there's a flaw in the very fabric of reality. You have to understand that everywhere in the universe, all known quantum fields love to settle at their lowest possible energy level, because that makes them extremely stable. Yet, for reasons we don't understand, the Higgs field breaks this rule. It seems to be stuck, trapped in a secondary valley, in a false vacuum state, unable to reach its lowest energy state. And here's where it gets terrifying. If this field were to suddenly break free from its rut and cross the ridge separating it from its true vacuum state, it would drag a part of the cosmos with it, instantly creating a bubble of true vacuum. At first it's tiny in size, but very quickly, this minuscule bubble will have absolutely massive consequences on everything around it. Because fueled by enormous negative pressure, it starts to grow and expand in all directions, feeding on and devouring its environment at the speed of light with nothing able to stop it. Because when this rapidly growing bubble of true quantum vacuum comes into contact with matter, energy, or even space-time, it doesn't really touch them. It converts them to its own energy level. It slides them into a minimum energy vacuum state, a state impossible to resist, which step by step keeps spreading in a cascade, never slowing down in all directions. Even if you could protect yourself behind billions of kilometers of lead, it wouldn't make any difference. The quantum death bubble would simply engulf them, meeting no resistance, because it forces every portion of the universe it encounters to take on a form that the universe cannot refuse. And what's even stranger is that a quantum death bubble is a cataclysmic trail that moves forward without friction, not leaving behind a shattered or destroyed reality. At the edge of its expanding boundary, nothing spectacular happens. The swallowed portions of our universe simply disappear on the other side of the curtain, with no special effects, no implosion, no explosion. No matter the size of the objects encountered, planets, stars, black holes, or even galaxies, absolutely nothing can resist this spherical wavefront, which reconfigures the very nature of everything it encounters, leaving in its wake a completely different universe. In fact, the parts of the universe that enter the sphere don't really cross any boundaries. They never reach the other side because they are instantly and brutally transformed into something else. Maybe that's the most disturbing part of this phenomenon. A sphere of quantum death spreading at the speed of light does not travel across the universe. It invalidates its reality to reconfigure it, rewriting all existing rules as it passes through, replacing them with others. And this process is all the more frightening because it is irreversible. There is no way back because you can't return the Higgs field to its previous state once it has reached its minimum energy level. Thus, the formation of a true vacuum bubble does not cause destruction in the usual sense. The boundaries of these expanding spheres are waves of transformation. They do not destroy the parts of the cosmos they encounter, but rather mutate them. Once inside the bubble, the parts of the universe that have been converted continue to exist, but in a radically different form. And I think you're just as eager as I am to know what the inside of a true vacuum bubble looks like. The problem is that, on paper, a universe where the Higgs field has fallen to the bottom of the well offers a wasteland rich with infinite possibilities. When it comes into contact with a true vacuum bubble, the value of the speed of light, the masses of particles, and even the range of the fundamental forces of nature are altered, depending on the changes and the laws of nature that have been broken. The alternate cosmos inside the sphere could just as easily be sterile, devoid of atoms and molecules, and bathed in a light moving at the speed of an arthritic snail, or it could be a fertile universe in another way. Clearly, this scenario seems so crazy that you'd think it came straight out of the hat of a rabbit magician on acid. But vacuum decay through false vacuum formation, although it is based purely on theoretical grounds, is still completely consistent with all the results from the most precise experiments ever conducted in fundamental physics. To the point that some physicists think that quantum death bubbles might already exist somewhere in the entire universe. But it is strictly impossible for us to see them advancing or to detect them, because their transmutation front, which rewrites reality by leaving behind a different universe, moves without leaving any trace, without shockwaves, without explosions, without flashes, since these bubbles move at the speed of light, which is the maximum speed allowed by the laws of nature in our universe. The slightest hint of their existence that you could detect arrives at the same time as the bubble itself. So, if a quantum death bubble were to form right there, instantly at the center of the gigantic Andromeda galaxy, which is 2.5 million light-years away from us, at no point would we see in its wake the deep sky being altered. Because all the grains of light that left the stars just before those stars were overtaken by a new form of reality would stay ahead of the transmutation front. And this bubble would simply erase us and rewrite us in its wake without any warning in 2.5 million years, The time it would take for it to cross the distance that separates us from Andromeda and to reconfigure along its path a volume of space with a radius of 2.5 million light-years. So given that extinction by a quantum death bubble happens without sound and without images, it's impossible to prove that such a phenomenon didn't occur last year at the center of the Andromeda galaxy or near the star closest to us. On the other hand, if you're still here listening to this story, we can say that no bubble appeared within 10 light minutes of Earth at the moment you started this video. You get the idea, and you never see the bubble. Now, before you fall into existential panic, here are 3 pieces of good news. The first is that if such a vacuum ever formed near Earth, our helplessness would be total. Yeah, that's good news. We can deflect a meteorite, but not a new universe spreading into ours, erasing it and turning it into something else. So, what's the point of worrying about something that can't be seen or stopped? The second piece of good news is that if, by any chance, the edge of such a bubble were to reach us, you wouldn't feel a thing. Because the bubble moves incomparably faster than your nerve impulses. So if it comes from beneath you during the 2 nanoseconds in which the matter making up your legs is being reconfigured, your brain will still believe you have them. Finally, the third piece of good news is that our observable universe is so vast that a huge part of it is currently so far away from us that if true vacuum bubbles form there today, they will never reach us. The reason is that on large scales, the expansion of space is so rapid that a vacuum bubble, even though it spreads at the speed of light, is never able to encompass the entire universe, even if it has an eternity to do so. In short, you can breathe easy. It's better to check the batteries in your smoke detector than to worry about the formation of these painless, unstoppable, and invisible death bubbles. But if, despite everything, you're still tormented by this scenario, you can reassure yourself by remembering that the Higgs field seems so comfortably stuck in its well that it's extremely unlikely to escape and reconfigure reality for unimaginably long periods of time. If the formation of quantum death bubbles seems so unlikely, it's because it requires absolutely phenomenal amounts of energy. To get the Higgs field to cross the ridge separating its false vacuum state from its state of maximum stability, it is estimated that you would need to concentrate all the energy released by the explosion of a thermonuclear bomb into a volume 10 to the minus 35 times smaller than a proton. Or, if you prefer, condense all the energy the sun emits in a year into the volume of a dye to get the Higgs field out of its well. No known natural phenomenon today, not even supernova explosions or black hole collisions, comes close to such energy densities. And were the hellish conditions of the early universe also below this intensity? So I guess you're wondering why I talk about it, if we're almost certain it will never happen. Well, because this latest good news hides a very bad one. Because in the world of the infinitely small at quantum scales, even a gigantic barrier can be crossed without needing energy, thanks to the famous tunneling effect that lets you go straight through, and that's where things can go wrong. Because if the false vacuum state contains even the slightest bit of instability, then no matter how highly improbable it is for this barrier to be crossed by tunneling, it will eventually happen. Sooner or later, here or somewhere else, preferably much later and somewhere else. If the universe is infinite, and it might be, then quantum death bubbles must already have formed somewhere. At this very moment, while you are listening to me, a great number of new bubbles have just been born in the endless vastness of the universe. Because an infinite universe has infinitely many places and chances for them to form. And so everything that is statistically possible eventually ends up happening. In the same way, in the case of a universe that is not infinite but practically eternal, over dizzying spans of time, anything with even the smallest chance of happening eventually does happen. And in both cases, in an infinite universe, as in an eternal universe, Everything that is highly improbable but not forbidden eventually ends up happening, and the inconceivable becomes inevitable. Afterwards, just to put your mind at ease, know that even if the Higgs field is metastable, it's estimated that no quantum death bubble should form in our observable universe for at least another 30 billion years. And the most optimistic calculations even rule out any appearance before at least 10 to the power of 100 years. By the way, surprisingly, in a universe that's 10 to the power of 100 years old, the process of heat death, which I really encourage you to check out, has already reached a fairly advanced stage. In short, even though it's impossible to guarantee with certainty that the Higgs field won't cross the barrier by quantum tunneling and trigger a spontaneous collapse of the vacuum, for now, if you want to rank your fears by priority, definitely put quantum death bubbles at the very bottom. As chilling as it is, the scenario of these quantum death bubbles forming is also, surprisingly, the only one that doesn't truly bring an end to our universe, because such expanding spheres are incapable of wiping it out completely. Wherever they form, they only reconfigure and consume the parts of the cosmos they come into contact with, while the rest of the universe continues to exist. And for regions that are far enough away, their appearance has no consequence at all, because as we've seen, the accelerated expansion of space puts them out of reach of their devastating effect. And then, since these spheres don't just erase everything they encounter, but also rewrite the nature of reality on the other side of their boundaries, we could almost be glad of their presence and see in the emergence of a false vacuum not an apocalypse, but the prospect of a new growing universe. Universes that grow inside another by feeding on it and imposing their own laws. Some models even suggest that among all the possible configurations that the fundamental constants of nature can take in these bubbles, some could have the exact values of our universe. Maybe even our cosmos was formed as a result of such an event that took place in a previous universe.